So we're going to talk about a very important idea in trig called reference angles. It's kind of a minor topic. Usually people have a rough time with it, not because it's difficult, but they don't see the point to it. I'll just say this is a really important thing to know. Don't make a huge deal out of it. Just try to watch what I'm doing and follow along, right? So you can find a reference angle, it's called. So the way I'm going to teach this for this lesson is I'm going to show you by example. All right, now I've drawn a quadrant 1, 2, 3, and 4 angle, and I've also drawn, given an example, of an angle over 360 and negative under 360, right? How would we tackle those? And then after we get all this done, we'll have a couple quick examples, specific special cases to look at. So first thing we're going to do is draw the angle. Now there's something called standard position. Right? I could draw a 13-degree angle in a lot of ways. Here's a 13-degree angle. Here's a 13-degree angle. Here's a 13-degree angle. So what we want is we want to lock it in place so everybody draws the same 13-degree angle the same way all the time. So to do that, we come up with something called standard position. So you make your coordinate axes. So this is x and y. You always start here at the positive part of the x-axis. You rotate this way for positive angles, and you rotate this way for negative angles, right? So if I want to draw a 13-degree angle, my initial side, like one of the two rays that make up the angle, starts at the origin. It's on the positive x-axis. This is positive 13 degrees, so I'm going to rotate 13 degrees up. And that will be my terminal side. That's the other. So here are the two rays that make up the angle, and here is the angle. It's 13 degrees right there. So the black angle is the given angle. Where's my? I'm going to use. I was looking for blue. Here's blue. Blue is a picture of the reference angle. So a reference angle is always positive. It's always between 0 and 90, and you always draw down to the x-axis. So if I go from this terminal side and draw perpendicular down to the x-axis, this is my reference angle. Now that's weird because in this case, the reference angle is the same as the given angle. Now, just forget about that for a minute. Let's look at the other ones and see what's going on. Draw it. First thing we want to do every time is draw it. So our first side is here, and then we're going to rotate this way 107 degrees. Now that is an obtuse angle. Reference angles are always between 0 and 90. I never cut over to the y-axis. I always go from my terminal side, which is not this one, but that one, to the x-axis. You're going to drop a perpendicular, and that is my reference angle right there. That's a picture of it. So if I can draw it, I can figure it, because that's like geometry, right? 180 minus 107. So in this case, my reference angle is 73 degrees. So that's different. This one, we always start on the positive x-axis. Now I'm going to rotate 90, 180, 230 would be around here. This is the given angle. For the reference angle, draw perpendicular to the x-axis. This right here is my reference angle. So I would do that, 230, take away 180, right? If I take this much away, I'd be left with that. So I have 230 take away 180. Reference angle is 50 degrees. All right, fourth quadrant. Start here. Rotate 90, 180, 270, 312 would be somewhere over here. The reference angle is always the acute angle there, right? So I'm going to drop a perpendicular to the x-axis. That would be 312. Actually, it'd be 360 minus 312. So my reference angle here is 48 degrees. So in the quadrant 3, people memorize this. I think the picture is a much better way to learn it. This is given minus 180. That's how I got that number. This is 360 minus the given. That's how I got this number. This one is 180 minus the given. Right? So it's, and this is same as the given. Now you can memorize those things if you want, but I think it's better to learn it from the picture because you'll forget these little formulas, but pictures you will always understand. All right, how do we figure one of these? Well, when you're doing one of these angles, you understand if it's over 360, that means you went around the circle more than once. So one way you can do it is just keep subtracting off 360 degrees until you get something less than 360. So if I go all the way around and then go another 247 degrees, see, this is 247. This is 360 and 247. It's the same. See how it ends in the same place? This one we just had to loop around a little bit more. Basically, if it's over 360, you just take it off to get the actual angle to draw. And then this, oops, that would be my reference angle. So in this case, it's 247 minus 180, which I believe is 67 degrees. All right, now this one's minus, so I'm going to have minus 999. I'm going to add 360, and then I'll go again. So I think we're looking at, what, 270? 630, yeah. So this is the same as minus 270 degrees. Let's draw that. Oh, that can't be right. I'm missing a 9. 279 degrees, my bad. So let's see, here's 90, 180, 270, and just a smidge. So that is where it ends. My reference angle, I draw to the x-axis. There's the picture of it. So that would be 360, take away 279, and that would leave me that little piece. And that would be what? I'm blanking out here. 81 degrees. Yes. Now I understand at first you just don't see the point, right? You can see what I'm doing. It seems kind of goofy. It's okay. Right now you make it your business to be able to find the reference angle, and later on we'll figure out why it matters. Now I do have to show you a couple special cases. Notice every one of these are in a quadrant. What if you're given an angle that is in between quadrants, or it separates two quadrants? For instance, 90, 180, 270, and 360. Now, in class, I got a certain way I show this, but let's see if we can do it. So there's 90 degrees. Here's 180. 270. And 360 is wrapped, it's like, like 315 kind of on a clock. Well, in this case, let's start with the easier ones. The reference angle is 90. You can go up to 90. So this is the given angle. This is the reference angle. So this is also 90. Now these are the weird ones. The given angle is 180. The reference angle is 0. And this 360, the reference angle is 0. So let's take a look at those. Let's say it was not quite 180. Let's do 170 and 175. So this would be my reference angle, and this would be my reference angle. In this case, it's 10 degrees, and in this case, it's 5 degrees. So I think the best way to think of this is think of it in motion. Imagine this is staying put, and this is my terminal side, right? So if I was here, my reference angle, I don't know, maybe it's like 60. Now my reference angle is 50. Now my reference angle is, see how my reference angle is falling, falling, falling? And when it gets this low, it's 10. And when it gets a little lower, it's 5. What would happen if it kept dropping until it went horizontal? See, I can't draw it, but it's like there's no room between the x-axis and the terminal side. That angle between the terminal side and the x-axis collapses down to 0. That is the reference angle. Same thing's happening here. Imagine I had 270 degrees, right? Whoa. That's 90. This is 90 degree reference angle. 80, 70, 60, 50. Well, that's 45 degree reference angle. See, right there. That's always to the x-axis. 30, 20, 10, 5, collapses down to 0. So the distance between the terminal side and the x-axis is 0. That is your reference angle. All right. I hope that was clear. This homework assignment is pretty straightforward if you just do what you're seeing. Like I said, usually what trips people up is they get it, but they don't understand why you would care about this. Just try to put that on the back burner. I promise we will deal with why it matters. All right, have fun with this.